Hi, future doctors. Welcome to the next class. In this class, we will discuss about satellite and orbital velocity. So, what is meant by satellite? Any object which is revolving around the Earth. Any object which is revolving around the Earth is called satellite. So, which is the natural satellite of the Earth means Moon. Moon is revolving around the Earth. So this is mass of the earth capital M, radius of the earth capital R. So any object which is going to be revolving satellite, so around this in a particular orbit of radius small r. So this satellite is at a height from surface of the earth is going to be h. So r is radius, h is height of the satellite from the surface. Then what is small r? Small r is going to be from center to the satellite distance, that is nothing but capital R plus h. Now, with what velocity the satellite is going to be revolving in this particular orbit is called orbital velocity. So, to find this, how we are going to calculate means to revolve any object around the any object. So, to revolve any object around any object. So, what is required means for revolving which force is required? Centripetal force. So, how the centripetal force is provided for the satellite means because of gravitational force between these two masses. Mass of the satellite is small m, mass of the planet is or earth is capital M. Then gravitational force between these two we have to equate. That is only so m centripetal force equation mv naught square by small r. Gravitational force, so g capital M into small m by, so distance between these two, that is nothing but r square, gravitational force. So if these two cancel, m cancel, so v naught is equal to root gm by small r. This one only we are going to write root gm by r plus h. So when you have to use this formula, So many students will get confused whenever they are writing this formula. So Gm by small r is the radius of the orbit if they have given. R plus it, sometimes they will give the satellite is revolving from the surface of the earth or surface of the planet at some height they will give. At that time you have to use this formula. So from the surface of the earth, it is at a height 2r. R is radius of the earth they will say. At that time h we have to take 2r. So don't get confused with small r and kappa. And for this they are going to give one small assumption. If this satellite is very near to the surface, that is going to be h equal to 0. Then this orbital velocity they are going to write root gm by capital R. So from this we came to know g is equal to gm by r square. Then gm is equal to g r square. If you substitute in this, so g r square by r. So if you cancel, this is going to be root gr. So what is the relation between orbital velocity and escape velocity? They will ask. Escape velocity is root 2gr. Orbital velocity is root gr. So v is equal to root 2 times of. In place of this root gr, we will write v naught. So one time they asked this question in your final NEET exam. What is the ratio of escape velocity and orbital velocity? So this is one case whenever height means very near to the surface. They will give in the question whenever satellite is revolving very near to the surface, what is its velocity? Then root gr. Otherwise, you have to take this formula. So generally, any satellite is revolving in a particular orbit means we will take this formula. This is the special case. Next, what is the energy of this revolving satellite? So kinetic energy of revolving satellite, first if you are writing, kinetic energy is equal to half m v naught square. So half small m. What is v naught square here? V naught square is g capital M by r. So g mm by 2r. This is nothing but kinetic energy of revolving satellite. Now what is the potential energy? So what is the gravitational potential energy means? Already we came to know minus gmm by small r. Then what is the total energy of revolving satellite? So total energy is equal to kinetic energy plus potential energy. So gmm by 2r minus gmm by r. So what we are going to get? So gmm by r is common, 1 by 2 minus 1. Therefore, minus gmm by 2r. Just you can see. So for kinetic energy, if you keep minus, that is only total energy. So they will ask relation between this total energy, kinetic energy, potential energy. So potential energy is minus gmm by r. Kinetic energy is gmm by 2r. Then total energy is so minus gmm by 2r. So in place of gmm by 2r, what we can take? In place of gmm by 2r, so we can write k. Therefore, total energy is equal to minus k. Next, in place of gmm by r with the negative sign, in place of gmm by r with the negative sign, what we can write? U. At the time, total energy equal to U by 2. So isn't it? They will ask this ratio. At the time, if you remember this, very easily you can write. So this one will be coming again in atoms lesson, similar to total energy, kinetic energy, potential energy. So this is about orbital velocity and relation between orbital velocity and escape velocity and kinetic energy of revolving satellite in a particular orbit and potential energy, total energy. Next, we will see time period of the satellite. Next, what is the time period of this revolving satellite? So, mass of the planet, radius of the planet, satellite is revolving in a particular orbit of radius r. So, from its surface, it is at a height small h. So, what is this time period means? If it is moving with orbital velocity equal to distance by time. What is the distance means? 2 pi r by t. So, you should remember time period is 2 pi r by v. So, this v is nothing but orbital velocity. Now, what is this radius? So, we can write small r is equal to r plus h. So, what is the orbital velocity in terms of small r? 2 pi r by root gm by small r. So, if you write 2 pi by root gm into r, so r power 1 by 2, that is going to be otherwise root r. We can write here r power 1 by 2. So, 2 pi by root gm, so r power 1 plus 1 by 2. So, that is going to be t is equal to 2 pi by root gm r power 3 by 2. So, this root gm, what we can write? So, g is equal to gm by r square. So, gm is equal to g r square we can write. So, whenever we are writing this g r square, so let us assume this is simple case they are going to take. This satellite is revolving very near to the surface. At the time h is going to be 0. This r they can write. So, 2 pi by root gm r plus h whole power 3 by 2. So, this one only they are going to write t is directly proportional to r power 3 by 2, t square is directly proportional to r cube. This is only Kepler's third law. So, we will discuss later Kepler's first law, second law, third law also we are going to get. This is the third law. On this also they asked in 2025 one question. So, if h is going to be 0, means satellite is revolving near to the surface. At that time, this formula they can be written as 2 pi by root gm. So r whole power 3 by 2. So this gm, if they wrote gr square, otherwise P is equal to 2 pi root gr square into r power 3 by 2, isn't it? So this r square, if you are sending outside, 2 pi by root g capital R power 3 by 2. If we are sending to numerator, so 2 pi by root g r power 3 by 2 minus 1, isn't it? So if r is going to numerator minus. So what you are going to get here? So 2 pi root r by root g. So finally 2 pi root r by g. Already this formula we got one time. So whenever variation of g with latitude g phi is equal to g minus r omega square cos square lambda. Whenever lambda is 0 at lambda is 0, g at equator g minus r omega square. So whenever g phi is 0, same formula we got. At that time, if you substitute r and g, 84.6 minutes. R value, radius of the earth, small g 9.8. So 84.6 minutes. So 1 hour 41 minutes something we are going to get time period. So this one also proved for Kepler's law can be proved by using this equation or this method, time period of the revolving satellite. So very important equation to remember. So this one we are going to get by using this time period equation. So this equation is very important because sometimes you will get relation between r and distance and time period. Okay. So this is about escape velocity, orbital velocity and time period, total energy of the revolving satellite. So we will see some models in next class. Thank you.